Okay, so we're going to get the derivative of both sides. Derivative of the left side, derivative of the right side. And so the derivative of the left side here, we have to use the product rule, because we have a product of two functions. And so here what we have is, well, we're going to do the derivative of the first, so the derivative of x is just 1 times the second, which is just y, plus the first, leaving it alone, times the derivative of the second. Now here, the derivative of y, remember that y is a function of x, so you imagine taking the derivative of the outside function, which is just 1, and then times the derivative of the inside, which we symbolize by y prime. And so remember that this is the thing, is that you don't know what y equals implicitly, but you know that you have to use the chain rule whenever you get the derivative of y, and so that's where this y prime comes from. Okay, and so then we have minus the derivative of x, which is 1, minus 3 is just a constant, so we'll leave it out of it. And the derivative of y, that's just 1 times y prime. The derivative of negative 4 is 0, and the derivative of 0 is 0. Okay, so now, notice that what we're looking for is we're trying to solve for y prime. And so what we're going to do is we're going to move all of the terms without a y prime. We're just going to move them over to the right side. So we're going to subtract y. We're going to add 1. So we're going to subtract y and add 1. And so what we're going to have is x times y prime minus 3 times y prime is equal to minus y plus 1. And then since we're trying to solve for y prime, well, all we have to do is factor it out because it's common to both, and then we're going to have x minus 3 left over equals minus y plus 1. And the last step is just divide by x minus 3 on both sides. And so we get that the derivative of y with respect to x is equal to negative y plus 1 over x minus 3. And that's it. Okay, so we want to find dy over dx, or y prime. So remember, the first thing you do is you get the derivative of both sides with respect to x. And so here we go. The derivative of this first part, well, here we have to use the product rule. And so what we're going to have is, here we have the derivative of the first, which is just 1 times the second, plus the first times the derivative of the second. Now here, well, the derivative of natural log of y, this is just 1 over y. But since y is a function of x, we have to multiply by y prime. Now we didn't do that back here because we didn't get the derivative of natural log of y. That was the part of the product rule where you just leave it alone. It's only here when we got the derivative of y. Okay, and then we have plus the derivative of y cubed. Again, the chain rule. This is 3y squared times y prime is equal to the derivative of natural log of x. That's just 1 over x. And again, like last time, we're going to solve for y prime. So all the terms without a y prime are going to get moved. So this natural log of y. This term has a y prime. This one does as well. So we're just going to rewrite the rest of this. So these guys cancel. We have x over y times y prime plus 3y squared times y prime equals 1 over x minus natural log of y. And then like last time, since y prime is common, we factor it out. And we'll have x over y plus 3y squared is equal to 1 over x minus natural log of y. And then we'll divide both sides by x over y plus 3y squared. And so here on this side, these guys will cancel. And then that's it. This is our answer. You can simplify it a little bit if you wanted to, but this is fine. This one is kind of a trickster because we want to find dy over dx or y prime. And so here we'll notice what's cosine squared plus sine squared. This is just equal to 1. That's the Pythagorean identity. So really this is equal to 1 equals y plus 2. And so if you get the derivative of both sides of this, well, you get, on the left side you get 0 equals the derivative of y with respect to x, that's just y prime plus 0, and so the derivative of y with respect to x is just 0. So that's it.